In this video, we're going to talk about how to recognize if a decimal is a rational or an irrational number. So, here are a couple of sentences defining it. The first one says, terminating decimals are rational numbers. What do I mean by that? Well, let's take a rational number, a number that can be written as a fraction. Converting it to a decimal, 3/4 would be the same as 0.75 or 75 hundredths. Clearly, this terminates. This decimal ends. It does not continue and go on. Another one, of course, would be something like 3/5. If we convert 3/5 into a decimal, we can see that this would be the same as 0.6. These would be rational numbers. Another form of decimal number that is a rational number would be something that would have a repeating pattern. Let's take a number like 5/11. If I take the number 5/11 and I were to convert that into a decimal, I would see that it would create this pattern, 0.45, 45, 45, and I could write this decimal as 0.45, 45 hundredths with a bar over it, indicating that this pattern repeats over and over and over again. The third type of decimal number that's a rational number is decimals that have a repeating digit. An example of that would be something like 2/3. I think most of you recall that this would be 0.666, just keeps repeating, goes on infinitely. We could write this as 0.6 with a bar over it. So these are three types of decimal numbers that are rational numbers. The rest of them are not. So they need to either terminate, have a repeating pattern, or have a repeating digit or digits, as I will show you in a moment. We're going to take a look at an example problem. So hold on one second. I'm going to pause and we'll put up a problem. Okay, so here is our question, and the question is, which number is not irrational? Assume each pattern continues. So let's read that again. Which number is not irrational? Well, if the number is not irrational that we're looking for, it must be rational. So let's take a look at these and see if we can find numbers that either terminate, have a repeating pattern, or have a repeating digit. Okay, in our first example, number 1 here, it starts off, it looks like we might have a pattern that's repeating, but if you take a closer look, you'll see it's not. This is 2 0 2 0 0 2 0 0 0 2 0 0 0. It keeps continuing. It's not really repeating. It's getting larger and larger. This would be irrational. This first example is irrational. How about the second one? We have 3.213, 213, 213. Now that's a repeating pattern. As a matter of fact, this could be written as 3.213 with a bar over it. So number 2 is certainly a rational number. How about number 3? We have 3.12, 122, 1222. And number 3 is like number 1. There really isn't a repeating pattern. This is an irrational number. So what's the rational one? It would be number 2.